minus 1.5. Okay, so one of them is plus, one of them is minus. Okay, minus means what? It is less than the mean. Okay, so no problem. Okay, so in this case there is only one side which has a positive value, so we will take that side. Okay, so according to condition B, side number 2 has a problem. Okay, according to condition 1 it was 1 and 5. According to condition B it is side number 2. Clear? Okay. Hmm? What? Frequency of the side minus mean upon standard deviation. So 50 minus 32 upon this. For side number 9 it will be 24 minus 32 upon this. Clear? Okay. Okay, for example, if there were 10 sites which were new, okay, so you will have 10 of these values. Let's say some of them are positive. Let's say 5 or 6 of them are positive. Then we can again pick the first two, the top two. Okay, in this case we don't have any other option. Okay, there is no other option. So condition B points to site number 2. Okay, now condition C was, yeah. Are there any? Yes.
If the two values is negative, we choose highest.
Why? Negative? Leave it. We leave it. Leave it. Yeah. Okay. Condition C is, are there any sites which have recently seen increase in frequency? Okay. Obviously for the two new sites there is no chance you can check it, because for the new sites there is only 1 year of data. Okay, so no change in frequency for them. For the other sites then we can check. Okay. They, in some other books and some other manuals, they have shown the tests which you can do to compare between the 2 years, and you can see if it is significant change or not. Because you see there is a change in all of them, right? None of them has exactly the same number every year. Okay. So now you have to, in this case you have to use your judgment. Obviously here there is no increase, it's decreasing. So this one is out. Decreasing, this one is out. This one decreasing. Increase. Okay. So we can mark this one. Okay, it's site number 5. Okay, so 5 has an increase. Okay. Then 6 also has an increase. 7 also has an increase. There is also increase here. Increase here and increase, and decrease here. Okay, so they are 1, 2, 3, 4, and 5. 5 sites which have an increase. Okay, again you can see how much is the increase and pick the top two. Okay, so increase here is how much? 15, right? 15. Here 6. Here 9. 40. 8. Okay, so we'll pick the first two. Okay, so here I have 15 and there was 40, right? I'll pick the 5 and 8. 5 and 8? 5 and 8. Okay, clear? Two sites didn't have the yearly data, I cannot do it. Other 4 or 5 sites had decreased, they are out. From the sites which had increased, I picked the first two. Okay, so but I'm just comparing between the numbers. Okay, the next thing was, look at if they are look at the rate now. Okay, now compare according to the rate of crashes. Now we have already used the rate method earlier. Okay, for each site, just to for example, if I pick site number 1, how will I calculate the rate? Give me total here, total. What is this? Okay, 111, total number of crashes. Okay, multiply by 10 to the power 6. Okay, why 10 to the power 6? Million. Okay, so this is just for the sake of conversion. Divide by, now this data is for how many years? 3 years. Each year 365 days, right? Each day how much traffic? Okay, so this is how we have been calculating the rate. We had done it in the previous examples as well. We will do the same thing here. Okay, clear? Okay, so the values are given here. This was just for example. Rate again you can see per million vehicles, 10 to the power 6. Okay, so these are the rates. So condition D says now pick the sites which have the highest rates. Again we can pick 2 like we have been doing with other conditions. We pick the first 2, the top 2. Okay, which one are those? 3 and 11. Okay. Okay, so 3 and 11 according to this. Clear? Okay. These numbers are written, that's why I'm writing them. They are written here in the points. Okay. And I'm just explaining you how did we get this. Okay, so we are picking the top 2 rates. Okay, which is 3 and 11. Clear? Now, the last condition is for the newly constructed sites. Now we will focus on their rates. 2 new constructed sites, site number 2 and 9, right? Okay, and we will do the same thing but with the rate now. Okay, so I'll take for example site number 3. So site number 3 has a rate of 5. The mean rate is 3.1. Divide by standard deviation, which is 0.9. How much? Okay, and this thing for site number 11? Now you see both of them will be positive, right? Both of them will be positive. Yes, only 4.26. The rest will remain the same. 3.1.9. How much? 1.3. Okay, both of them are positive, both of them have a problem, but which one has a bigger problem? Site number 3. Clear? Okay, so for the sake of understanding, if it is negative, we know it is even less than the mean, so no problem. If it is positive, so you get this ratio 3.1. Okay. 3.1 means what? The frequency on your side is 3 times the normal variation or the normal mean of the data, the normal range of the data. Okay? This means the frequency on your side is 3 times the normal frequency in this area or for these sites. So this means the rate on your side is 2 times the normal crash rate in this area. Okay? So this number is like the number of times a normal number can be. Okay, so 2 point something means is 2 times. Okay, and this 1.3 means what? It is almost the normal, maybe 30% higher. 0.3 means 30% higher. Okay, so this is how these results are interpreted. Okay, so we applied these conditions and so on and so forth. Okay. Condition 4.26, right? The highest one was for what? Site number 11? No, site number 9. Sorry. We are not picking this site. This will be minus, yes. Because we are doing it for the new sites, right? The new sites are 2 and yes. So it will not be 5 as well. This will be 3 point what? 3.6. Yes. Sorry for that. How much is this? 0.5. And the other one, it will be minus something, right? It will be minus. So this is only for the new sites. We don't have to do it for the top 2. Yes. minus 0.5. Okay. So like they are saying, only site 2 has. Okay. Condition A, if you apply the new lights, it will be more beneficial on site number 1 and site number 5, because these sites have more crashes which can be solved by these lights. Okay, so according to condition A, we will pick these two sites. According to condition B and E, both of them, which are for new sites, so both of them show that site number 2 has a problem. So condition B and E, both of them giving me the same answer, that site number 2 has a problem. Okay. Then condition C, they have picked site number 8, okay, where the change between the airs was the highest. Okay. So, and collision rate at site number 3, so this is on the basis of rate, again they have picked the highest one. Okay, so site number 3 according to this, site number 8 according to this. So now how many sites we have? 1, 5, 2, 8 and 3. Okay, we know which sites have a problem and we know what is the problem. Okay, these two sides have a problem with the rear end and collision and the angle collision and so on, and the other sides I already mentioned. Okay, so on these two sides we will definitely change the lights because it has the highest impact here. Okay, so on these two sides I will do the thing. Okay, site 2 may have a short-term problem because it's only been open for 1 year. Okay, it may have a short-term problem. Okay, and it should be addressed immediately because it has been just opened and there have been so many crashes. So whatever is the problem is very urgent. Okay, so it should be done immediately. Site number 5 has seen the increase in crashes. 5, it should be 8. Should be 8. Make the correction. Site number 8. Okay, so in site number 8, something happened between the last 2 years which has increased the number of crashes, and again it needs further investigation. Okay, but because we need to know the reason, right? Okay, site number 3 has the highest crash rate, again it needs more investigation. Okay, and so on and so forth. Clear? Okay, now you can see for site number 1 and 5 we identified the problem and we have a solution for that which is already planned by the government. So 1 and 5, no problem, we will do whatever is required. Okay, site 2 and 8 and 3, we know they are the problem. Okay, we know they are the problem, what to do about it and what is the problem, exact problem, what is the cause of the problem, we don't know. Okay, so for these sites more investigation will be done. Okay, so all these methods, this one and the previous 5 methods, are for the selection of the sites. They are for the selection of the sites. In some cases you select the site and you immediately know what to do, like for site number 1 and 5. For some other sites you will select the sites to do more working. Clear? Okay, so this is what is happening with the other ones. So this brings us to the next point, when we don't know what to do. Okay, what is going to be the solution for this particular site? So the solution is called as countermeasure. Okay, so there's a problem and you will try to solve it. To solve this problem you will do some improvement on the site. So that improvement is called as countermeasure. Okay, so it will counter the effect of crashes. Okay, so we are looking for the most cost effective solution. Cost effective doesn't mean the lowest cost. Cost effective doesn't mean the lowest cost. Okay, it means the best value of money. Okay, means the best value of money. Okay, so maybe you buy something which is the lowest, the cheapest, but it will only last for 6 months. Okay, and then you buy something else which is double the price, but it will last for 5 years. Okay, so obviously the second one is more cost effective, although it is more expensive. Okay, yes, the worth. Okay, so same thing here. The worth is how many crashes I can reduce. How many crashes I can reduce. So condition A in the previous example. Why did we pick site number 1 and 5? Because site number 1 and 5, because of that solution, will have the highest decrease in crashes. Okay. Okay. If you do the same solution on site number 2, how many crashes you are expected to remove? 35 only. But if you do the same solution on site number 1, same solution, right? Same cost. Okay. But it can reduce how many? Potentially 87. So 35 and 87. So the cost is same, but the effect is higher. So that's why we are saying cost effective, not the cheapest. Okay, how do we develop a countermeasure? How do we reach a solution? We have to do some extra analysis, which is done using collision diagram and condition diagram. Okay, and we also need some potential countermeasures which have been used in your area or internationally. Okay, so I need like a pool of solutions from which I will pick one. Okay, it will make my life easier if I already have this data. So first of all, let us talk about the diagrams which we need to plot to analyze. So these diagrams, collision diagram and the condition diagram, they help you investigate the reasons of the crash. Okay, why the crash is happening. Okay, so first thing we'll discuss is the collision. Collision means the crash, the accident. Okay, so diagram which shows accidents, collision. Okay, so what are the items we include in this diagram? It should include some information about the site. For example, the name of the street, the width of the road, okay, direction of traffic, okay, from each lane, from each side, and so on and so forth. Collisions, okay, and the fixed objects which are on the site. Okay, I will show you some examples. With the diagram, so it's a diagram, it's a sketch. Okay, with it you can put some tabular data as well for the reference of the reader. Okay, so he doesn't need to read everything from the diagram. Okay, he can look at the table and get a summary. Okay, so the table provides you a summary of what you are showing in the diagram. Okay, and this is the main item. The diagram should show how many crashes you had, at what spot exactly. So one diagram is not for the whole country or for the whole city. One collision diagram is already for one segment or one intersection. But in that intersection, where did the accident happen? Okay, so location means the exact point. Okay, the pattern, the day, the time and the date on which the accident happened, the conditions of the road and conditions of the environment, the light conditions, weather and so on, at the time of crash, at the time of that crash, and the severity of that crash. So this is the main item of the diagram. Okay, number, location, pattern, time, condition and severity. If obviously one site may have many crashes. Okay, so the diagram could become crowded if you try. So if you have, for example, 50 crashes, you try to make 50 crashes in one sketch, it could become crowded. Okay, so you can use symbols to show multiple crashes. So this symbol means 3 crashes. Okay, on the same spot or the same reason and so on. Okay, so this can be done as well. This is a collision diagram. Okay, so some data about the data, some items about the data. Okay, the period, the person who did it, and location, and the scale, and so on. The summary table, I already mentioned, right? So now looking at this table, you know how many total crashes we have? 30. Where are 30 crashes? In the diagram. Okay, how many of them are fatal? 0. How many of them are injury? 20. How many of them are property damage? Only 10. Okay, so you get the summary here. Then we have some more tables here which are showing the legends. Okay, legends meaning what?
Direction of the name.
Direction of the name. Symbols, yes, symbols. Okay. So, okay, what are these symbols about? Surface condition of the road. Okay, it could be dry, it could be wet, it could be damaged. Lighting condition. Okay. Type of collision you have, type of crash you have. Okay. So 2 arrows, one after the other, another means rear end and so on. This is very easy because you see the arrows, you know what type of collision you have. Okay, but again, they have put a legend for that. Type of vehicle you have, a bus, a truck, a pedestrian, a bicycle, one. Okay. Movement, again, arrows, very easy. And type of severity. Okay, so severity is not written, it is part of the notation. Okay, so a blue one means fatal, which you will not see obviously because fatal is 0. Dotted line means injury. Okay, so wherever you see dotted lines, it's injury. And solid lines means property damage. Okay, so these are the things which you need to incorporate. Okay, the road names are given. You can see the speed as well. Okay, and this is what I meant by where the accident happened. Okay, so we say, okay, on this road there were 1, 2, 3, 4, 5, 6 accidents. Okay, on this road near the intersection, but where? In which lane? You can see the lane as well now. Okay, you can see which type of vehicle was involved. Okay, so here the vehicle was making the turn when the accident happened. Here they were both going straight when the accident happened, turning before the turning, and so on. Okay, so that's why it is more detailed. Okay, and then you can see more details here as well. So we are not just saying, okay, accident happened on the intersection or inside the intersection. Where? In which situation? Which point? And what was the direction of the vehicles at that time when the accident happened? Okay, so this gives you more details. Okay, you can see the location of the signals as well. And any other roadside object which you find is important, you can mention it. Okay, signals obviously are important for the safety. Okay, so you can see medians as well. You can see this one. This is what? Stop line. Okay, and the gas station as well, right? Now you can see gas station is not exactly on the intersection. It's not exactly on the intersection, but vehicles will come out from the gas station, go into the gas station. That could affect safety, so that's why it's there. Okay, so then the objects, so obviously you may have some buildings here. Are they shown? No, because according to them, the buildings, they don't have entrance and exit here, so do not make it. Okay, so you will focus on the things which can affect safety. Okay, then we have a condition diagram. Condition diagram is a supplement to the collision diagram. Okay, so you read both diagrams together. Okay, so in the condition diagram, you are showing the condition of the site. Okay, so this one doesn't have the collisions, it doesn't show the crashes, but it shows more information about the site. So the previous one has less information about the site, more information about the accidents. This one, the other way around. Okay, so we can use rough sketches, we can use aerial photographs. Okay, we focus on design of traffic and the operation of the road. Okay, you may add additional information. For example, debris meaning any loose material, any aggregates or pile of cement or something on the roadside or on the road because of the crash. So the crash damaged the pillar of the bridge and then there's some material coming out of it. Skid marks. Okay, Signal light we already mentioned. What type of lights they have, okay, for the signal. And yes, if you did any other studies on the site, for example, you did any conflict study, okay, then that should be mentioned as well. What do we mean by conflict? Yes. No, I'm asking you. What do you mean by conflict?
What do you mean by conflict? Conflict.
Yes. Then shut up. No, seriously.
I am asking
You are not kids. Okay. So some things which should be part of the condition diagram. I already mentioned it for road safety audit as well. You should have a checklist to make sure that you don't miss any item. Okay. So follow a checklist which shows you which items should be part of the condition diagram, and then you include them. Okay, this is a condition diagram for the same site. Okay, the site which had the collision diagram. Again, some information about the road itself, the survey itself. Okay, now you can see information about, for example, the gas station. Okay, where is the entrance? Okay, where is first entrance, where is the second entrance? Okay, other objects which are on the side of the road, they were not there in the collision diagram. Okay, although it was for the same site. Okay, the lane widths are shown. Okay, speed limit was already there and so on. Okay, so you get the idea. Okay, if pedestrian crossings are available, then you show them as well. If there are any other signs or markings, they are also mentioned here. Okay, so the main aim of making these diagrams is to come up with the countermeasure. Okay, countermeasure means solving the problem of, or something which you will do to solve the problem of safety on the site. Okay, so we focus on two things mainly which could be affected by the countermeasure. One is the road, the other one is the human, the driver. Okay, the driver is affected by the design of the road, right? So we focus on these two things. What is the third item which we are not focusing on, but that can affect accidents or crashes? That is part of the road design. What else? Weather, environment. Okay, so obviously this is not part of the process. Okay, cluster analysis is used. What do we mean by cluster analysis? Trying to identify things which are similar to each other. This is called a cluster. Okay, so like this is a cluster, right? Okay, all boys here. This is another cluster, right? All girls here. Things which are similar. Okay, so in the accidents on the sites, we try to identify patterns which are similar to each other. Okay, so we had total 30 crashes. Okay, 15 of them are similar to each other. What is similar between them? Okay, cluster analysis means trying to identify common features in the crashes. Trying to identify common features in the crashes. Okay, and they will become the most dominant issues. Okay, we start with the cause, which is the immediate one. Earliest known means the immediate cause, immediate reason, immediate cause. Okay, so the immediate cause could be the pavement was wet and the car slipped. Okay, so this is the immediate cause, the immediate reason. And then you can see why the pavement was wet. Is it happening is it constantly there, or it happened just for one crash, or so on and so forth. Okay, and later on you can update it by doing more investigation. So you look at one cause at a time, one crash at a time, find out the most immediate reason, and then you can expand. Okay, you can look for other reasons as well, and so on and so forth. The main source to do this analysis, not the source of the data. Data is coming from the crashes. The main source to do this is experience and judgment. There's no equation here. You cannot apply any equation to do this. Okay, but now there are methods which are called as machine learning methods, which can help you do this. Okay, let me, because I have it right now. Okay. Okay. This is a diagram which we made using machine learning methods. Okay. And this diagram shows that which factors have the highest effect on the crashes, severity of the crashes. Okay. So we can see shoulder width, weather, cloudy weather, if there is a vertical curve, something about the driver, if the section was straight, if the accident happened during daytime, during winter time, and so on and so forth. Okay. So now you put the data in the method, and the method tells you which factors are more important. Okay. But there is a lot of calculation behind getting this diagram. Okay. To solve the problem, we go for the 4 E's. Now they have increased 1 E. It was 3 E's earlier. I will increase 1 more. Okay. So by the time you will graduate, it will be 5 and 6 and so on. Okay. Or maybe you will get to F. 4 E's and 1 F. You will have add your own F, right? So what are the 4 E's? Try to solve the problem through engineering, changing the road design, vehicle design, enforcement. Okay, enforcement meaning changing something in the laws, traffic laws, educating the driver. Okay, what I'm doing?
No phone.
No effect. Huh?
Phone was the
No
right
phone. Very good. Emergency response, increasing the medical services. Okay, so the severity will be less. Obviously, some of the injuries and deaths happen because the driver did not get first aid at the right time. Okay. Okay. Yeah. You have 10-12 sites with you. Okay. One of the site is more complicated. So we will focus on that one later. Focus on the sites which have more obvious trends. So you know what is happening here. When you look at the data, you know it's very easy to identify what is the problem. Focus on the easier sites first. Okay. Yeah. The countermeasure, the last 2 points tell you that once you select the countermeasure, once you apply it, you need to do a post review as well. Okay. After applying the countermeasure, you need to review the site again, like we did in the previous example, the 2 new sites, remember? Okay, so you have to, well, whatever changes you have made to the sites, you have to see maybe the changes you have made, it may solve one problem and start the other. Okay, so that's why a post review is recommended and you have to do it. Okay, okay, so we will continue a bit more about it just tomorrow. Any questions?